Hello. How are you all doing? All right. Well, thanks for coming and good afternoon. My name is Madan Armugam. I'm a program manager in SQL Server. The topic of the day is migrating SQL Server database applications to Windows Azure virtual machines. And I have with me Guy Borman, who's my colleague, also a program manager in SQL Server.
Hello.
All right. So how many of you watched the keynote, either live or through webcast? So yeah, this is the exciting announcement in the keynote, right? The Windows Azure virtual machine. How many of you have tried, playing around with the Windows Azure virtual machine? Somewhat. Yeah. Hopefully, after this talk, you'll get inspired to go and sign up for a free trial and try out. And in this talk, we are going to specifically talk about SQL Server running in a Windows Azure virtual machine. How many of you are using Azure for any other reasons? Okay. Sounds good. So hopefully, there will be some interesting content for you. And, feel free to, after the session is over, we'll hang out here. If you have any specific questions on the content or anything related to Azure, we'll be happy to answer. So the agenda, as you saw on the rolling slides, we'll talk about the SQL Server Cloud Continuum. How many of you are using SQL Azure? Okay. Yeah, so one of the things that we wanted to do is talk about the continuum of offerings, right? there are so many things you can do in cloud. The infrastructure as a service, platform as a service, and how this fits into that particular picture. We'll give a lot of demos. Guy here will be kind of really showing you how the experience is from a SQL Server point of view. Just simple deployment and connecting basics, and then actually migrating an existing application. And setting up database mirroring. What is different, what is not. And then also we will talk about what you get in this preview period. This is a feature that's in preview period. From a SQL point of view, what you can do, what is supported, what is not. And we would love to get your feedback. This is a preview program that is being rolled out, and the SQL Server team is managing a set of customers to have a deep dive partnership, to get feedback. So if you're interested, you'll see some information on how to enroll in that as well. All right. So there was a session this morning that Guy and I were presenting, and this is, if you were attending that, you would see that this is the same slide. And this is essentially a slide to frame our discussion for the next hour and 15 minutes. And it's important that we speak the same language, right? When I say something, I want you to understand this is what I meant. So this slide helps me lay that out. So what you have in the slide is a simple a plot of two dimensions, right? So on the bottom corner, you basically have this ability to control, and control as in controlling your execution environment, controlling your hardware, controlling your software, right? And it varies from a high degree of control to a low degree of control. And on the other axis, you have the cost, right? So this is typically the trade-offs that customers are making today. When they think about cloud, they're driven by cost savings. But there is also needs for their applications around how much control they want and how much control they're willing to give, right? And really, all the cloud deployment models are essentially being plotted in these two dimensions, right? So if you think about it, this is a journey or a continuum to cloud from wherever customers are. Maybe they are running on a physical, IT managed environment. Maybe they have already virtualized their SQL Server applications. But every one of them is a step in the direction where they'll get the highest economies of scale in terms of cost savings. So you can see, in a physical environment, absolutely, you have the full control of what you want to run, what hardware you want to run, what version you want to run. And obviously, in terms of cost, it is high cost. You need dedicated infrastructure, you need dedicated personnel, it needs management, if you will. The next step typically is virtualizing assets, right? And this is a journey that the whole industry has taken. About 2-3 years ago, I remember talking to customers about virtualizing SQL Server database applications. And you would see, there'll be a lot of concerns around performance. Customers didn't even want to run any kind of databases, let alone SQL Server, in a virtual machine. That has changed in the last 3 years, right? With the emergence of VMware as a very solid player, and Microsoft has its own offering in this space with Hyper-V. So customers are already doing, the virtualization. In fact, the statistic is that SQL Server is the most virtualized database in the planet. And partly the reason is SQL Server is the most popular database in the planet as well in terms of number of people using it. But it's also the most virtualized. So, we, in the Microsoft SQL Server team, we pay, very special attention to that to make sure that, SQL Server runs well in a virtual machine. Now, infrastructure as a service is an evolution of virtualization. It's not just SQL Server running in a virtual machine, but also creating this service phenomenon. And I'll talk about what that means. There are a few characteristics that we talk about. And then platform as a service is where, not only have I gotten rid of my capital expenditure with IaaS, but I also want to kind of make a dent on my operational expenditure. I don't want to manage, the OS, the guest OS, or, the VM itself. Can I just focus on the business logic? And then software as a service is where, it's like email. All I want is an email, hey, Microsoft, or hey, Amazon, or hey, cloud provider, take care of the rest for me, right? And that essentially is the plot. Now, in this context, I want to define a term called hybrid cloud. And this is what, the whole venture of SQL Server running in a Windows Azure virtual machine is all about. A hybrid cloud is essentially a cloud infrastructure that is composed of one or many clouds, right? And this could be a private cloud, it could be a public cloud. And in simple, it means, ability to run an application that can run on both on-premises cloud as well as off-premises cloud, or both at the same time. A canonical example here is cloud bursting. Tax season comes up, I'm a tax software, I need to offload a bunch of, read activity or actually compute activity to a data center that is, outside of my premises, whether it's cloud or, hosted service provider, it doesn't matter, right? So hybrid cloud is one of the key reasons why Microsoft is very interested in, in providing this capability for customers, because a lot of existing customers, they want to be able to migrate to cloud at their own incremental pace, as opposed to, doing a complete rewrite, right? So this is something that, we are aware of, and this is in response to that need. And when we think about the same continuum, same graph, if you will, here is the SQL Server view of it, right? You'll see that, SQL Server will continue to run in box. We will ship products. We just shipped SQL Server 2012. You've probably seen some sessions on that. And here, obviously, we talked about it. The value prop is full hardware control. You get to configure all the SQL Server features that you've loved, all the things that you heard about. I don't know if you guys attended the SQL Server Always On session. It's our flagship HADR solution. You could do that. Now, SQL Server Private Cloud on-premises is where you have some self-service capabilities. It's not the same as the public cloud self-service capabilities. You're using System Center, you're using Hyper-V. We even have an appliance offering that actually connects all of that. And then the next step, which is the topic of the day, is SQL Server running in a Windows Azure virtual machine. Here, the key value prop is that it's 100% compatible. If you can run something in a VM, it runs on VMware or Hyper-V, it doesn't matter. It'll run in that VM, right? And that is powerful because in Azure, so far, our offering has been the Windows Azure SQL database, previously known as SQL Azure. And that's, as you know, it's not fully compatible with the box SQL Server. And that was one of the top pain points for customers saying, hey, I like this SQL Server feature X, pick your feature, right? Power View, for example. I want to be able to run in Azure. Can I do that? And, this will fill that gap, that we talk about. So just a quick overview of the preview. You guys all seem to be aware of what the Azure VM capability itself, but just a quick jot down in terms of what is relevant for our session. So really, it's about a virtual machine that you can own in cloud, a virtual machine that you can rent. It's yours to own. You get to tell what runs in it. You get to manage it. The Azure platform doesn't mess with it. It does provide some capabilities, around the VM. Specifically the virtual machine SLA. If your virtual machine were to die because the host machine that it's running or the physical hardware got corrupt, it'll automatically get service healed, right? So this is something nice, but yet, everything inside the confines of the VM, it's the user's responsibility, right? That's why it's infrastructure as a service. There's a whole lot of networking improvements. Most relevant to SQL Server is the fact that you can domain join a VM that is running in the cloud to your corporate network. So from your existing tools point of view, existing SQL Server applications point of view, it doesn't know that this is actually running in the cloud. And it's essentially it's a hybrid app. The fact that you're crossing over internet, yet making that VM look like it has the same IP address as your corporate address is something very powerful, because you can domain join, you can use Windows Auth. Your existing tools, whether you're using, say, Tivoli or System Center, should continue to work as is. And this enables you to allow migration of assets, SQL Server assets, into cloud at your own pace, right? As opposed to taking a leap of faith, if you will. We are supporting Linux. You've heard about this. There are a few sessions around that. On the other hand side, you'll see the performance improvement. So this was primarily driven by the SQL Server product running in Azure. So we wanted to make sure that the Azure virtual machine is performant for a database application. Remember I was mentioning 2-3 years ago when we had this conversation about a database running in a virtual machine. We didn't want to have that conversation again in Azure. So we said we'll start with a high bar. If it has to run in Azure, it has to be performant for a departmental database application to begin with. And I'll talk about some of the numbers here. And obviously the top applications that are being supported in the preview release period is SQL, SharePoint, and Active Directory. And you'll see gallery images also in the demo that there are stock images with SQL Server and Windows Server that literally in a matter of minutes you'll be able to kind of create a dev or test or a production environment, right? Just having that. And that's what we mean by a cloud-first VM creation experience. All right, so what sizes and what SQL Server editions do we support, right? And here's the simple table. You have the different sizes that are offered in preview, right? It starts from a shared CPU core all the way to an extra large, which is an 8 CPU core. And in terms of memory, you can see that starting from less than a gig to 14 gigs. And that is also the network bandwidth, both ingress and outgress to that VM. And the important thing that you want to notice is the number of data disks. I mean, it has tremendous amount of capacity. Each data disk can support up to 1 terabyte. So potentially, your extra large VM, you could be running a huge set of data. You can locate a huge set of data in that particular VM. And the one point that I missed in the previous slide that is important for SQL is this data is persisted and it's also geo-replicated without you having to do anything. So the fact that you are actually running in a Windows Azure VM, you have an availability SLA, at a VM level SLA, but you're also making sure that this data is geo-replicated. If you're running in say Amsterdam, it's basically automatically getting replicated to Dublin, for example. And in terms of SQL editions, extra small, based on the existing minimum requirements we have for SQL Server, you can only run Express. But any of the other VMs, you could potentially pick any edition you want. Standard, enterprise, web, doesn't matter, right? It should be able to run. And there is a link to the support statement which has more details and frequently asked questions. You'll have access to the deck, and once you get access to the deck, you should be able to access it. All right, so what are the scenarios and patterns that are interesting for this particular offering, right? And this is a result or a synthesis of multiple months of customer conversations. Who have been helping us in shaping this offering. There are 4 scenarios that come to mind. There is variations of the scenario you hear over and over again, but it ends up coming down to these 4. The first one is pretty simple. It's about migrating my existing apps. It's not worth my time to rewrite my app, but I want to take advantage of the cloud benefits. So give me an environment where I can just run as is. Very minimal changes, right? I don't want to go talk to a developer. As an IT pro, I should be able to follow like 2-3 steps and get there, right? So that's the number one thing. The second thing is, I've already virtualized my databases. It's running on my own hardware. Hardware refresh cycle is coming up. I don't want to buy any additional hardware. I just want to throw it into Azure, right? And let it run as is today, right? Again, this is something, a lot of customers are interested in, to take advantage of the capital expenditure investments as well as managing the hardware. I don't want to be in that business. I would rather do something, that is worthwhile for my organization. So we keep hearing flavors of this particular scenario. The third one is dev test. Again, a lot of appeal for that. We hear from customers saying, it takes me 3 months to get a database for dev test, right? Wouldn't it be easy if I can take, like 2 steps, 10 minutes, and I get something that I can play around, and when it's ready, I can take it back on-prem, right? So that is a very, very appealing. And the flavors of this scenario that we hear is our sales folks saying, I want to go to a customer and demo something. Just give me my own environment where I can tune, I can capture, and whenever I need it, I'll stand up a VM, right? So a very popular scenario, of course. The third one is what we talked about. This is the net new capability that we are enabling with infrastructure as a service. Like I talked about, the hybrid cloud, the ability to domain join, essentially allows you this secure trust boundary between your cloud, your environment, and the public cloud. And the addressability, in terms of addressability, it just looks like your own cloud. It just, there is magic behind that actually connects these, the VMs that are sitting in Azure and VMs that are sitting in your own infrastructure. And if you think about this is a very powerful scenario, right? Think about a SQL Server scenario where today you have a HA deployment, database mirroring, or if you're using SQL Server 2012, you're using always on. And for your disaster recovery solution, you probably have lock shipping or database mirroring, asynchronous database mirroring, and there is a huge hunk of hardware that is sitting at some other site where you have set up this DR. Now, what if that DR site is actually in cloud, in Azure? What if you could just say, hey, create a secondary in the cloud, and if you're using always on, create a secondary that is in cloud and that is readable. So suddenly you have this capability to offload a lot of your work to your secondary in the cloud in Azure. And you can tear it down when you're not using it. You can bring it up when you need it. Use it for DR if you need it. So the possibilities are pretty exciting. Once you have this trust boundary between on-premise and off-premises, your security concern should be addressed. It's no different than what you have in DR today, except it's way cheaper, right? So that's something that we are excited about. And in terms of patterns, I have just a few examples. There's no way to say that this is the only patterns we support, but just to kind of get you guys thinking about, what are the different patterns that you can construct, right? So the first one is a simple, everything contained in a single VM. You have front end, middle end, mid-tier, and the back end, right? This one is probably the most complex. I've got all the stuff in Azure, but I have a front end that's running on a web role. It's a stateless role, right? It can expand elastically. And I have my mid-tier running on the Azure VM. And then, the SQL Server backend that's connected with database mirroring. Matter of fact, I think Guy will actually show you a demo of that. And the third one, which is interesting, this is the Project Brooklyn, which is the code word for Windows Azure Virtual Networking. It enables you to securely connect, extend your existing applications on-prem. And this is the scenario that I talked about, backup in the cloud or disaster recovery in the cloud. It's a pretty exciting scenario. All right, so how do you, so you got this capability, you guys heard about it. So how do you get to run in this VM? Well, there are pretty much two paths, right? You either bring your own image, and by image I mean your actual snapshot of the VM, a VHT image, if you will. Or you start from cloud, use a gallery image, right? And both are valid, and both are supported. And what you see here is just the current preview specification of what we are supporting, right? So if you're bringing your own VHT image, pretty much the steps are simple. You sysprep your existing VM, you upload it to the Windows Azure storage account that you own, and the support story is that we will support any SQL Server editions 2008 and above, any SKU, right? Whether it's standard, enterprise, it doesn't matter. And the licensing story is that you have to have license mobility with software assurance. So this is a preview statement. It's not necessary that this will continue, but for preview, which we are currently in, you have to have license mobility to be able to transfer the license. But assuming you have that, as long as you can sysprep that VM, you'll be able to upload it in Azure and you'll be able to run. And not only that, once you get it running, maybe you do a few things, dev test, and you can bring it back, right? So that full VHT mobility is something that is very appealing to a lot of customers. If you start from the image gallery, you'll see one stock image with SQL Server 2012 Eval Edition. And it basically has all the services that comes with the SQL Server install media installed with the default set of options. So this means you will have SSIS, you will have SSRS, the reporting services, analysis services, the management studio. In fact, the image gallery stock image will have the entire install media saved off in a folder. So you can enable, disable whatever you want. And in GA, in general availability, we are planning on introducing more editions, more versions of SQL Server. And again, I think this is where if you guys participate in this preview program, you'll be able to give us feedback on saying, what, SQL Server 2012 is great, but it's not enough. Give me SQL Server 2008 R2 or SQL Server 2008. So, we would love to hear that feedback from you guys. We'll also have an option to be able to pay as you go. It'll be a monthly contract. You can pay per hour, just like how you see in other vendors, right? Amazon or Rackspace. And we'll also, you will have to manage the VM, the SQL Server in the VM itself, but the stock image will be refreshed on a regular basis with all the latest and greatest patches. So that's the story here. So why don't we see a demo of it? Guy will actually take us through a quick round of how this will work.
Thanks, Madan. So, okay, that's a bit confusing. I've got the windows mixed up, but never mind. So here's the old Windows Azure portal. And here's what the preview portal looks like. Here's the new one. And we're going to start with the basics. Suppose you want to create a new SQL Server virtual machine. So we'll go to virtual machines, and we can connect. Can you see this okay? Okay, so, sorry, we'll go to new. So we're creating a new virtual machine. So click on virtual machine and click from gallery. We're going to create one from there's a SQL Server 2012 Evaluation Edition in the gallery, and it's running on Windows Server 2008 R2 Service Pack 1. So we'll select that. Now this is in preview. When it goes to GA, there's going to be more editions than this, not just Eval Edition. So we'll go to Create, and we'll give it a name. I'll give it the imaginative GBVM3. It asks for an administrator password. You've got those range of sizes that you saw on the slide. Just for testing purposes, I'm just going to go with small, although for production workloads we recommend medium or larger, just mostly because of the memory. Then you've got some additional options like standalone virtual machine or connect to an existing virtual machine. If you're going to deploy several virtual machines, then if you want them all behind the same Windows Azure firewall, you're probably going to want to pick connect to existing virtual machine. That's not important for me, so I'm just going to create standalone. I'll give it a DNS name, so this is going to effectively represent an IP address, and this is going to be the name that I connect to. I could use an existing storage account or just accept the default, which I'm going to do in this case, and use automatically generated storage accounts. This is going to create an account for me in Windows Azure Storage, basically the blob store. The region affinity group virtual network, this is important. It's basically where is it going to locate it. So you need to think about network latency and think carefully about where you're going to put this. Again, I don't really care. I'm going to put it in West US. And then this is my subscription. So that all looks good. I'll go to the next screen. Then I have the option of an availability set. An availability set, suppose you're deploying an HA solution, so you've got multiple machines and you always need at least one of them to be up, then it's good to have them in an availability set, because if there's maintenance occurring on some of the Windows Azure VMs, then what an availability set does is it prevents all of those machines going down. So it's like they're on separate storage or they've got separate resources connected with them. Since I'm just creating one at this case, I'll just put none for availability set. And that's it. I'm done. It started provisioning this VM. Now this can take, I don't know, about 12 minutes, which is a bit long for a demo, although not very long compared to asking your IT department to provision a machine. So what I'm going to do next in this demo, I want to connect to a VM. I'm going to start by just doing a remote desktop to it, but what I really want to do is connect from SQL Server Management Studio running on my laptop, i.e. running on-premise, to this VM in the cloud. And I want to go through the steps of what you need to do to make that work. But I'll start by just connecting. So this one I created about an hour ago, GBVM2. If I go and look at the properties, one thing I'm going to do while I'm here, it's nice that it gives you a readout of some of the resources that are being used. One thing I want to do here, though, is when you configure a VM, or when you deploy a VM, it has its own firewall, but it's also behind a Windows Azure firewall. So while I'm here, I'm going to create an opening in that firewall that I'll be using later when I connect from SSMS. In other words, I want to create an opening specifically for SQL Server. It's already got the remote desktop opening, so I don't really need to do this now. The only reason I want to do it now is it takes a few minutes, so I don't want to kind of do it at the end and then wait. So I'll go to Add Endpoint. What tends to happen if you don't read the documentation, this is the step that people forget to do if they're connecting from on-premises, add the Windows Azure endpoint. So I'll add an endpoint. I'll pick a name. Protocol TCP. Private port, well, the default SQL Server listening port is 1433. I'm going to give it a different public port just to follow security best practices. Not very different. I'll put 14330. And now it's creating. So I'll leave that creating, and now I'm going to connect to my virtual machine. What happens when it creates it? It basically assigns it a random public port for remote desktop, but you can see what that port is here. So if you were creating your own remote desktop session to it, you could use that port. Now, I assume up to this far, you've pretty much seen all this in the keynote, right? Okay, that's an interesting error. Specified username does not exist. Yeah, I'll give it one more try. If it doesn't work, there's something else I can try doing to connect to this. Okay, what I'm actually going to do here is I'll try connecting to another one I created last night, GBVM1. I think what we just saw there is a bug, because you should just be able to press connect. Oh, right, click on connect.
Click on connect and save it.
Oh, here. Yeah, that's a good idea.
Yeah, but you may have to check the password, is what he's saying.
Oh, okay. So edit. Ask for credentials.
Yeah, now try connect.
Yeah, in that case, actually, I'll go back to GBVM2, because that one is I haven't set that up to connect yet. So I'll save this one. Edit.
Yeah, always ask for credentials.
Okay, and then let's try connect.
Looks like there's something else going on.
So when you try this, hopefully you won't see that. I do remember running into this a few weeks back, but I hadn't seen this problem since.
So if it doesn't work, why don't we go ahead with the slides and maybe you can try it out?
Yeah,
and
then I'll work on it. Sure.
Yeah. We should try the VM3.
That's true. VM3 will be ready by that time. Okay, so I've successfully connected.
Thanks for the tip.
Yeah, thanks. Glad you're sitting there. When you first provision it and log in, you'll see a pop-up just saying, please wait while SQL Server configures. And basically, SQL Server's acclimatizing itself, or generalizing it's a generalized, and it's acclimatizing itself, setting up what it needs to for this particular VM. Once you see this getting started in the background, then you know it's finished doing that and it's ready to use. It takes about 2 minutes to do it. This is a link to a very useful document, by the way, the Getting Started document. So once I've connected, I'm going to run SQL Server Management Studio. SQL Server Management Studio is set up to do Windows authentication by default. If I want to connect from on-premises, unless I do some kind of domain join, I'm going to want to change this to mixed mode authentication. So that's the first thing that I'm going to change. I'll connect to this and then change the authentication mode. So I'll click on Properties. Security. Select Mixed Mode. And then it warns me to remember to restart before this takes effect. Then I'm going to go into Security, Logins, and I'm going to enable a login. So I'll pick on the SA user. So this isn't necessarily following best practices now to connect like this, but because it's fully compatible, you could configure end-to-end encryption to connect if you wanted to. So I'll specify a password. And under status, I'll put login enabled. Okay, then I need to remember to restart the instance. Next thing I'm going to do is, although I opened an endpoint in the Windows Azure firewall, I need to remember to open an endpoint in the virtual machine. So let's go to the virtual machine firewall. Inbound rules, new rule, port, TCP, specify local ports, I'll specify 1433. Allow the connection, pick the defaults, give it a name, SQL. Okay, so now that should be all the things I need to do inside this VM to be able to connect to it. So the next thing I'm going to do is I'll take the URL of this VM. So the URL is down there at the bottom. I'm going to fire up Management Studio, click Connect. I'll put this URL and remember to put the port, the public port 14330. Change the authentication to SQL Server authentication. Put in this SA user. And then connect. So I've managed to connect. So now in Management Studio, I've got my local server that I can see, and I've got the server running in the cloud. So really, that was all about the security settings. Once I opened up what security settings I needed to, it's pretty trivial to connect. So over to you.
Thanks, Guy. All right, so now that you've got a sense of what it means, it's really, really simple, right? All you've done is provision a new VM, opened up a couple of ports, and your existing SSMS installation should be able to connect. So this is really the set of steps that Guy walked us through, right? Now the remote desktop, you need to open up a virtual machine firewall. You have to create an endpoint in the dashboard that you saw Guy do. And for Management Studio, it's pretty simple as well. You have to create a private port 1433 and map it to a public port. Open up a firewall rule, and off you go, right? So really, it's just that. Once you set that up, in fact, you can even script this out, right? Almost every single action in Windows Azure portal is PowerShell scriptable. So you can actually write this, and every single time your VM comes up, you can actually automatically run this as well. And if you're bringing your own image, which was one of the options, yeah, question.
The Windows Azure endpoint, is that a port you can set for a VM, or can you also set a port for all your VMs?
It depends on how you construct your cloud service. So cloud service is where you compose, say, if you have multiple VMs in your cloud service, right? You're connecting all the virtual machines to each other, so they're kind of connected to each other. You will have one external IP address or external DNS name. So you could potentially have multiple ports pointing to multiple VMs, but a single IP address, single public IP address. But you cannot have, you can have port forwarders. There's a feature called port forwarders, but you cannot have one external IP address mapped to multiple multiple individual VMs. There is a feature called load balance set that would allow something similar, where you would kind of round robin if you want load balancing between individual VMs. But in this case, for example, if you want to connect to a SQL server, you would there'll be one IP addresses, and you can have like up to, I don't even think there is a limit. You can have multiple public ports mapping to individual private ports sitting on different VMs behind that cloud service. Yeah. Another question? The question is, can we have named instances? I think we should be able to, right? I don't see any restrictions. Yeah, it should be. Anything that you can do in a VM, pretty much what we said, you should be able to do it here. As long as you connect up the right ports to a public IP address, you should be able to address that. All right. So, again, another reminder here, as he showed in the demo, when you're creating the VM, a SQL Server VM, especially given that all your databases are going to be stored in a storage account, please pay attention to the region where you're automatically creating the storage account, because that would matter, especially if you are having a lot of database transactions. You want to make sure that the latencies are not intercontinental, right? It's obviously going to hurt your performance. All right, so now let's look at another demo, and here I think Guy will actually show you how to actually migrate a SQL database, from on-premises to off-premises.
Okay, thanks, Madan. So what I want to do here is, suppose we have an application running on-premise and we want to migrate it to the cloud. So that's what we'll do next. And right now let's minimize the connection to the cloud and open the local connection. I'll go to a database called DemoDB. I'm going to right-click on it, click on Tasks, and then there's an option, Export Data. So what I want to do is export data from my laptop, effectively, and then import data into the cloud image. So I'll click Export Data. What you're effectively doing there, you get the SQL Server import and export wizard. Anyone use that? Okay, quite popular then. So I'll click Next. It'll select from the data source, which defaults to local, and for the local I use Windows Authentication, so it's pretty much the defaults there. And then for the server name, let's see if I've still got this. Yes, I still have this in my buffer. So this is my cloud instance. And I'm going to use SQL Server Authentication.
Is it a dot or a colon?
It's a comma. Is that what I put? I think I put a comma. So I'll use that same login that I enabled. And I'm going to select New Database. I'll give it the same name, DemoDB. Oops, Demio. So copy data from one or more tables or views. That's the default option. Click Next. Pretty much picking all the defaults here. Run immediately. Finish. So what it's doing here is it's basically taking this database and exporting it and then importing it into the cloud. Okay, it only had 3 rows, so it went quite quick. But what it shows here, though, is that for some databases, it's that simple. So it's to just migrate an application could be that simple. However, this is using this DAC mechanism. Not all databases are going to support it. If you've got certain features like, I don't know, full text search, for example, you can't necessarily use DAC. So that's the yes question. It doesn't support what, any indexes? I thought there was a certain type of index.
Yeah, well, just certain type of indexes. Yeah. It used to be that restrictive. The question was if the DAC export import supported indexes. I think it supports certain type of indexes. I don't have the detail on top of the mind, but you're right. I think it is. It doesn't support all the features, which is your core point. So there is, and I think that's what Guy's point is. He's going to show an alternative mechanism to kind of upload the data.
Yeah. So if you've got a pretty standard database, that's a good option. If it's basically DAC compatible, then that's a nice way to move it. So what about the hard way? So a way you can export and import any database would be, for example, to back it up to a VHD, upload that VHD, attach that VHD, and then restore. So I'll go through the basics of that. If I go to computer management on my laptop, I've created a 30 megabyte VHD that's currently my D drive. So let's do a backup to that D drive. So I'll pick DemoDB, tasks, backup. I already have this as a device, so I added the device demodb.back. So I'll back up. It completed. Then I would want to upload it. If I was going to upload it manually using the CS upload command, it looks like a bit of a mouthful, the command line. But basically picking add disk. And then in the connection, I'm grabbing my subscription ID, my certificate thumbprint, and then the service management endpoint, where the path to the VHD is, and then where it is in the blob store that I want to send it to. I can get most of this information. Actually, it's probably right now it's easiest to get most of this information from the old portal, which is why I started by showing the old portal. It's easy to get to the old portal. You just click on preview, and then it says take me to the previous portal. So I would typically click this and then upload it. And that's actually, it's a useful error message because it reminds me of a step that I forgot, which is to detach the drive before I try and upload it. So detach VHD. Let's try this again. So then in this case, it said it already exists in the repository, which is fair enough because I recently uploaded it. For this 30 meg disk, it would have uploaded pretty quickly. So now I can go to the management portal, or actually to the virtual machines. And what I would pick if I wanted to connect to this is I would click attach, and then I could click attach disk, and then I would go look at available disks and find this one and attach it. Since that can take a few minutes, I'm going to connect to another VHD. And it looks like when this happens, it usually means the network timed out. So let me see if I can reconnect to this. That's this one. Fortunately, I'm adapting quickly to whatever's wrong with the network or whatever's wrong with the portal right now to put the credentials in.
So why don't we get back to this?
Yeah, if this is taking a while, we can get back to the slides and then we can finish this.
All right, so let's keep going with the slides. So this is an example. I mean, this is really a slide that shows that almost every single operation that you saw him do in the management portal, you should be able to do in PowerShell. And it's actually quite powerful. The number of commandlets that are developed to mirror every single operation that you have in the REST API, it's staggering. And I think the Windows Azure folks have all this documented, and you have a link to the PowerShell information as well. And again, when you get this slide deck, you'll be able to access this. All right, so what about performance? I know it's a SQL Server session, and one of the first questions that we ask about any environment is, how should I think about performance? Is gonna, is it capable of running a departmental database, if you will, right? And the answer is yes. We've been working with the Windows Azure team specifically on the virtual machine for almost a year to make sure that the virtual machine is capable of driving reasonable SQL Server performance. And the way we have characterized the performance numbers, I mean, I can't share specific numbers externally because these are internal tracking workloads. But I could definitely say that it should be you should be able to put a departmental database, or what we would call as a tier 2, tier 3 database. Not your most mission critical database, but definitely a database that can fit into that VM. You should be able to get good performance out of it, both in terms of throughput as well as in terms of latencies, right? And we've done a battery of tests to kind of prove this over and over again to ourselves before we go launched in preview. And one of the things you want to think about is first, obviously a benchmark workload is not the same workload as what you have in your organization. So what I would encourage is get a VM. We have a trial offer going, and try out. Actually put your app in there and see how it performs. The thing that you want to, the few things that you want to know about is you can, decrease the size of the VM or increase the size of the VM. So pick medium, start from a medium VM, and then try your application, compare it with on-premises, and go up, all the way to extra large. The other way to do it, and this is traditionally what we have suggested, is use SQL I/O. You could use SQL I/O. The biggest unknown in this whole Azure virtual environment for most people is the subsystem around storage. So a SQL I/O is a great tool to kind of get a sense of what this subsystem can do. So I would highly encourage that. It's a free tool. You can download it. You can run it in a medium VM or an extra large VM. Try it with a different number of drives and get a sense of what this VM can do, so you can figure out what SQL database you can actually migrate it here. There is also, for the Windows Azure storage subsystem, the drives that are showing up within the VM, they have an analytics tool called Storage Analytics, which is available for public download, where you can kind of get the information around the performance of the drives themselves, right? And in thinking about SQL Server configuration, the current guideline is don't worry about setting maximum memory. Let SQL Server do the automatic memory management. So just leave it at its default. And in terms of putting up your user databases, the existing best practices in the physical or virtual environment apply. Put all your user databases on the non-system drive, right? Don't put it on the same drive where SQL Server is installed or Windows is installed. Put it on, in this virtual machine's case, it's E drive or F drive, right? There is also a temporary cache drive that will show up in every Azure VM that you could use for things like TempDB. It's not persistent, but that's exactly what you want, your TempDB to be located. So the suggestion is to put TempDB there. One of the key points here that I don't want to forget mentioning is, if you look at if you went through the steps that Guy just demonstrated and created a VM, a SQL Server VM, you'll see that there are two drives. A C drive, which is where SQL Server and Windows is installed, and a D drive, which is what I call as a temp drive, and a temporary drive, right? And if you choose to attach extra drives, like what Guy showed in this demo, it will show up as E:, F:, whatever, right? Now, the default cache settings for the C drive or the system drive is that the caching is on. Now, for SQL Server, we recommend that you turn that off, right? Because a lot of customers would say, I don't want to attach an extra D drive. I have my database completely fit within a single C drive, which is fine for me. If that's the case, turn off the caching and you'll see a performance improvement. By default, it is turned on. If you attach a data drive, a E:, or F:, by default, it's turned off, so you don't have to do anything additional. But if you're putting your user database in C drive, you might want to turn off the cache. And there is a link in this deck, that gives you the exact command line on how to do that. You can do it through PowerShell and disable the caching there. You should consider using the database page compression. It's obviously an existing database feature. You should be able to use it. There's nothing special about how you turn it on. If you did it on-prem, it should work off-prem as well. All right, how secure is it? Well, here is the whole 9 yards, right? So there is the physical network, host, application, data, and user. These are the different levels of the technology that you're doing when you're actually putting a SQL Server running in a VM. Now, the bottom three, the physical network and host, the Azure platform is responsible for securing. And what you'll see here is all the defenses that we have, right? In terms of the physical, we have a global foundation service across Microsoft, across the world, that guarantees you, the certain amount of compliance, right? And we've already compliant with several international compliances, right? Including ISO 27001. We are working on several US-based compliances. At this point, we have a FISMA moderate, but we are working on some additional compliances, coming in the roadmap. So, at the physical level, there's already a whole bunch of compliances that you can get. At the network level, you saw, guy opening up the firewall. So there is a host firewall limiting traffic to the VMs. Obviously, you can control it. You own the VM, but you have that mechanism to be able to make it compliant if you choose. Anything around the virtual LANs or the packet routing itself is also very secure. You shouldn't be worried about any of that. At the host level, we are not running we are running a very stripped down version of Windows Server 2008 R2. Specifically to protect you from all this patching vulnerabilities, right? So this is a completely contained system, much more secure than what you will see on a typical shipped software of Windows Server 2008 R2. And the hypervisor also creates that sense of security isolation, making sure that none of the tenants or none of the VMs running in a given host can actually attack the system or another VM, if you will. So the top three, the user, data, and application, is the layers that a customer would have to take care of it, or a SQL customer would have to take care of it, right? And because you own the VM, anything about that level, you are in charge of protecting the system and making it compliant. And here the story is pretty simple. Anything that works in a Windows Server platform or a Windows Server VM should work. And here are some other examples, right? From a SQL Server point of view, one of the questions we get asked is, "Oh, can I use TDE?" Absolutely, right? Whatever security practices that you have today, you should be able to implement it in a VM. It's just a VM in the cloud, right? All right. So what about HADR? I remember earlier in the session, I talked about a VM level SLA, which means anything outside of the virtual machine, if something happens, if the host machine crashes, unplanned failover, or if the host machine is being serviced and the VM were to take down, now the Azure platform will guarantee you that they will have 3 nines uptime. What that means is, over the period of a year, you will only have a downtime of about 8.5 hours a year, which in itself is pretty good. But what it doesn't do is within the VM, say for example, you're running SQL Server and it crashed. They're not going to be able to detect. Azure is not going to be able to detect because it's infrastructure as a service. We won't know what you run in the VM. So there you need additional protection to protect you from OS crashes or SQL crashes or SQL out of memory, all the usual vulnerabilities that you protect yourself from an application point of view. And here the story is pretty simple. In preview of all the technologies that we support in SQL Server, from database mirroring, lock shipping, transactional replication, all of that should work. The only thing that we don't support for preview, but we are targeting for GA, is the SQL Server 2012 Always On. Right? The Always On is our 2012 flagship solution that depends on clustering. You need to have clustering support in order to be able to support that. And currently we don't have that, and this is the feature that we are working on for general availability. But the scenario around, you basically have 2 SQL Server instances running in a VM, and you want to create that high availability, using this concept of availability set. Meaning, if Windows Azure is servicing this VM, it won't take out this VM at the same time, right? In order for you to create that kind of high availability solution, in preview you have to use database mirroring or lock shipping, right? But like I said in GA, you'll be able to use the always on availability group feature. The second scenario is on-prem to cloud. Remember I talked about this hybrid scenario. Again, the same technologies apply. You can have a database mirror here and a primary here and a secondary there and a witness anywhere in between. You could do that today in preview. In GA, you would be able to do the same thing with always-on availability groups, where you're able to kind of have a readable secondary in the cloud, right? And that is a pretty exciting feature that when it comes in GA, a lot of customers wanted to take use of it. And then the cloud to cloud is basically where I have all my SQL Server VMs running in, say, for example, in Amsterdam, right? The European data center, and I want to be able to kind of replicate all the way to, say, American data center or Singapore for that matter. Today the option is Windows Azure Storage being geo-replicated, and this is an automatic option. You don't have to do anything. You have an optional configuration to go and say, I don't want to pay for it. I don't want GeoDR. In future, we are looking at providing even the VM level support, because the geo-replication at the storage level is only replicating your VHTs, right? There is an additional level of replication that you can provide by having one VM sit in Amsterdam, one VM sit in maybe Singapore or the Americas to actually have those VMs connect to each other. So that's something that it will come later in the roadmap. All right, so time for another demo. Hopefully the demo gods will help.
Yeah, actually, I think it was fine. The one before, it just the connection's sometimes slow. So
yep.
I'm just gonna finish where we were. We'd uploaded a disk, and then we're gonna attach that disk to the VM in the cloud. So here's the VM in the cloud, disk management. We did the attach. So there's this backup E drive. So if I've got this E drive now, which has now been uploaded to the cloud, then I should just be able to run SSMS and then restore from this E drive to restore the database. So it's executing the query, and then it's done the work. In this case, there were 200 pages. So going at like 2 megabytes per second. So that's what we call the hard way. If you're just going to basically back up anything to a VHD and then upload it, attach it, restore it.
Yeah, the one important point that Guy mentioned is you could use a CS upload to bring your VHD with the system drive. You could choose to do that. Instead of starting from a VM in the cloud, maybe you have everything contained in a single VHD. Your SQL Server install, your database backup. You just do a CS upload and you can hydrate it up there as well. So that's an option as well.
Okay, so next we're going to look at mirroring. Now, what you see here is basically there's a primary, a standby server, and a witness all configured running in Windows Azure VMs. And note, in this case, it makes a lot of sense to put them all in the same availability set, because obviously you don't want all of these to go down at the same time. But once they're all there, configured and talking to each other, I could go take a look at these, and then I've got the mirroring monitor. The VM2 DB1 is the principal, and it's fully synchronized. So having seen that, let's reboot that machine. So I'll go to the dashboard for this machine, and then all these commands along the bottom, I'll pick restart. So am I sure? Yes, very. So if I've done that, if I then connect to what was the mirror, then if I refresh this, after a while, then it should. Oh, actually, yeah, they should swap over. So now, let's see, I'll just refresh a couple of times. Still synchronized. Let me just check that the other one is rebooting. It says that it's starting, so I'll just go back there. And okay, so it started, it's detected it, and it's figured that it's not connected. So now it's made itself the principal. So failover took place. So that's a basic summary. The setup steps, apart from making sure you put them all in the same availability group and having them all behind the same firewall, it's exactly the same as setting up mirroring on premise. It's that level of compatibility which is really useful. And if you set up high availability like this, then you could build on top of the existing SLA and have effectively a very high level of uptime if you make use of features like this and make use of an availability group.
Yeah, I think the important thing about this scenario is think about the hybrid scenario, right, where you have your primary on-prem, maybe a witness on-prem as well, and a secondary off-prem. You could do this today. I mean, and the same set of tools that you have, SQL Server 2008, it doesn't matter what version. It's a net new capability that you are enabled by just running on an Azure VM. And as new versions of SQL Server come out, you'll see us actually invest in much more capabilities in this direction. You have a question back? Okay, the question is, can we put servers of different sizes in the same availability set? Actually, so let me clarify the terminology because it's it could be quite confusing. Availability set is the Windows Azure terminology to have. So the question is, can we have multiple sizes of VMs? Yes, you can. All availability set does is locate your virtual machines in different fault domains. So, if they were to kind of be taken down, you won't have both the VMs. The whole point of that is to kind of give you high availability. So, if you actually place them in the same fault domains, then you haven't gotten anything, right? So, other than that, the Azure platform doesn't know anything about it. You are using that concept, the fact that it is placed to kind of create a high availability solution. So, as long as your application is okay with it, you'll be fine. Yeah. I mean, what you would want to consider is, say, if this was a medium VM and this is an extra large VM, and if the extra large VM was your primary and it failed, you want to make sure that the medium VM can support that load. So as long as you guarantee that, I think we should be okay. Yeah. And the other aspect of availability set that you want to think about is it optimizes for the latency between them. The fact that you're saying these are in the same availability set, there are two things happening. They are placed in separate fault domains, and then they are also optimizing for the latency between them because they're constantly checking each other's heartbeat, right? You don't want them to go all the way to their load balancer every single time. I mean, you will have horrible performance, right? So, yep.
On the topic of latency, could you say something about if I'm on-prem and I will open a connection to my SQL server and retrieve some data, maybe typically it's below 100 milliseconds.
Yep.
Could you say something about how much more time it will take to access the cloud?
So great question. I'll repeat the question, because this is being recorded. So what's the latency expectations between on-premises and off-premises, in this case Azure? So obviously that depends on your internet connection. What we can say, and this is not an SLA in any means, but in our test what we have found is the moment your packet hits the Azure data center, from there getting to a SQL server running in a VM, it's in a matter of less than a millisecond. So it's not a whole lot of latency. So as long as you have a strong pipe between your on-prem and your internet service provider hitting a data center, I think that likely is the biggest bottleneck. I would say that if you are running in, say, for example, Amsterdam, and your SQL Server database is sitting in Singapore or I don't know, somewhere transcontinental latencies tend to be around hundreds of milliseconds. I think 100 milliseconds is the ballpark of what we have seen. So which is why that it is very important to make sure that your storage account is closely located in the same continent. Otherwise, you're going over the sea. I mean, it's just physics, right? But as long as you do the right things and you have a solid internet connection, I mean, you see this. I mean, this internet connection is not optimized for Azure, but given that we're still able to kind of back up and restore small databases, though, but you'll be able to do that. In the testing that we have done, we did the same set of tests. I mean, all our tests were running on the Redmond CorpNet domain, which is the Microsoft CorpNet, and all our testing actually happens in production clusters. So we see the same issues customers would see, but obviously the T1 pipe that you have, the internet connection, that has a big point in it. So, all right, so I'll keep going. Is there anything additional? Oh, looks like it got back.
It got all synchronized once it rebooted.
So these are just a couple of case studies. I know we are still in preview, but we already have a couple of case studies, internal case studies, and I wanted to share it with you guys. So TechEd North America had a recommendation engine. Unfortunately, they didn't have that for TechEd Europe. We wanted to have that here, but it didn't happen. So this is a recommendation engine. TechEd North America, as you know, was attended by around 11,000 people. So everybody goes to this website and says, this is what, the sessions that I want to attend. That was actually, the architecture of that particular solution. This is, essentially a web front end, a website that would run. But it was powered by SQL Server 2012, running analysis services and integration services, and a backend to another web repository that was sitting on-prem. So this was an app that we actually tried during launch. That was running SQL Server 2012 in a VM, and it ran fine. It was able to scale to that many users. So really, as you saw in the demo over and over again, the only thing is this is in the cloud. As long as you have an internet connection, it just works. It's the same existing set of tools, nothing different, right?
And I think it was a great use of the cloud because they could just spin up those resources when they needed it.
Exactly.
And then after TechEd, they save them, and they're gone.
This is a classic example of a burst scenario, right? It's not like they're destroying the VMs. They captured the VHDs. Maybe the next decade they'll spin up it again, right? This is again another case study. This is a fairly complex application. This is an MS IT Azure IaaS SharePoint deployment. So this is a full-fledged SharePoint deployment with SQL backend. And this picture, all it is telling is it covered a lot of scenarios. There was part of the data assets were sitting on-prem in the CorpNet domain in Redmond. And we created what we call as a Windows Azure Virtual Network Tunnel, right? So this is what Mark Russinovich was talking about in the keynote. This is a secure trust boundary. Microsoft IT, just like any other enterprise customer, has very strict security boundaries. We don't want hackers to hack into our domain. So we were able to create a trust boundary all the way to Azure. And it basically is a direct VPN to VPN connection. We had an Active Directory on-prem that got extended all the way to off-prem, to the set of VMs. They basically had a Redmond domain IP addresses. We had SQL servers on-prem. We also had SQL servers off-prem. So we had data on both sides, right? The reporting data was coming from on-prem. These were like your sensitive on-prem data. It remained on-prem. We have analysis services both on-prem as well as off-prem. And the next slide, you'll see, like the set of VMs. And this is a fairly complex deployment, but we were able to kind of drive this just with 4 VMs, right? So you have a SharePoint web front end, 2 VMs. We had a SharePoint app server and a SharePoint DB. They're not showing the fact that it was actually database mirrored, but think of this as a primary, right? And the steps that they went through was pretty similar. We've been demonstrating this. They determined how many number of VMs they need and the size of the VMs they need. They configured the trust boundary, the Windows Azure Virtual Network, and then they provisioned the VMs. They uploaded the VHDs. In this case, they didn't start from the cloud stock image. They had everything in a VM. They were just CS uploading all the way to Azure. And then they installed the SharePoint form, and everything got working. So again, another example that these kind of complex app patterns are possible, and some things that we would encourage you guys to start trying. All right, so in terms of looking forward, what should you expect? The preview is all about fundamentals. We focused on making sure that there is a basic experience that you can bet on us. This is a SQL Server database running in a VM, which means that you want to make sure that it's performant. All the fundamentals around security, HADR, the high availability, disaster recovery, performance and manageability existed. The existing tools work as is. It's a certification of the SQL Server product. Any feature you can run in a VM, in a VHD, you should be able to move it to on-prem and take it back, right? So the focus areas were, like I said, fundamentals and the basic application migration and development, like we said. What we'll focus on going forward is the notion of the hybrid cloud. We'll expand on these scenarios to make it very easy for you to, from your on-prem SQL Server database, to say automatically back up to cloud, right? So what that does is, there is mechanisms that will allow you to kind of automatically say that, I'll back up to a cloud storage, and then from the Azure blob storage, you'll be able to kind of hydrate a VM, right? Again, another scenario is disaster recovery in the cloud. The scenarios we talked about. I have always on deployment. I have a readable secondary in the cloud. Again, something very, very exciting. So really, all those optimizations are what we are looking at in the next 6-12 months. We'll also have we'll bring in the manageability experiences of what we call as SQL Azure and SQL Server in a VM much closer. So you could potentially have an application that can mix and match all these assets, like what Mark Russinovich called in his talk as mixed mode, right? You're able to create an application that spans on-prem, off-prem, IaaS, and PaaS, all in a single application, right? So how do you choose? This is the question.
If you switch to the enterprise hybrid cloud, is there also a possibility that you can split different roles?
You could.
Don't want the SQL admin to reboot the domain controller.
Repeat the
Yep.
question.
The same cloud.
Yeah, so the question is, if you had the enterprises adopt hybrid cloud, can we also have access to multiple roles? Is that the question? Yeah, you can. So a mixed mode is where you can have an IaaS role as well as a PaaS role, and you can domain join your cloud service, right? So obviously a stateless role like a web role or a worker role, you won't have as much control as you have in a virtual machine. But still, you can choose which parts you want to put it on a stateless role, which parts you want to keep it on-prem, which parts you want to keep it in a VM. Absolutely, you get the control in terms of how you incrementally migrate. Yeah. All right, so this slide is really, this is quite a eye candy in terms of the details, but the point of this slide is to help customers figure out what should I choose. I'm a database customer. I want to go to cloud. When should I use SQL Server in a Windows Azure virtual machine? And when should I think about Windows Azure SQL database, right? And I'll just speak through in terms of the 5 areas, right? Or rather 6 areas. So it really comes down to these decision criteria: time to solution, cost of solution, scale, control, hybrid, and manageability. And I'll quickly talk about each one of those. When you think about time to solution, the world, this is a very simplistic worldview, but it does exist, right? You have your existing applications and services, and then you have your brand new applications that's going to start, right? Windows Azure SQL Database is a PaaS service, but it does require you to rewrite your application, right? So you have to make a choice. Is it worthwhile for you to rewrite your existing application or just migrate as is? If you want to migrate as is, you want to go through the SQL Server in the Windows Azure virtual machine, right? An example of this decision making would be, oh, you know what, I use Service Broker. I care about compatibility. Now maybe, SQL Server in Windows Azure virtual machine is the right target for you. If you're saying, I'm willing to kind of rewrite my app to fit into the SQL Azure model, then SQL Azure is the right thing for you, right? Cost of solution, your net, how much cost are you spending in order to get to Azure, right? And that has various dimensions: hardware, software, availability, and cost. And you'll see the differences there as well. Again, scale. In terms of scale, here you get your own dedicated virtual machine and you pay for it, right? In case of SQL Azure database, the Windows Azure SQL database, all you get is the ability to kind of use federations to kind of move up and forth. So the maximum size of the database supported in SQL Azure is 150 gigabytes, right? So if you're thinking about a terabyte of database, clearly that's not the place. You have to rewrite your application. But if you don't want to rewrite your application, you can use it in an extra large VM. You can go up to 16 terabytes, right? Control and customize, it's very obvious. In infrastructure as a service, it's all about control. It's full compatibility. In SQL Azure, we will support a subset of features, not all the features. In some features, we would probably never support in SQL Azure, right? So again, I think that's something that you have to think about when you make a decision. Hybrid, the ability to be able to domain join exists only in infrastructure as a service. In a platform as a service, you would never give you access to the VM that is running your database because it's such a multi-tenant system that you don't want to go and muck up with that VM or guest. And then manageability, I think this is an area where you'll see a lot of convergence, right? Whether you're running in SQL Server in a Windows Azure VM or SQL database, you'll see a convergence. But definitely you'll see a lot more benefits running on Windows Azure SQL database because it's a very highly multi-tenant environment and you're not managing your VMs. So I think that's an important point you should consider as well. So why should we give this a try? One of the questions I get asked is like, okay, you got what Amazon's got. So what's the big deal? SQL Server, I can run there, I can run here. And I would say there are 4 reasons, right? First, we think SQL Server running in Windows Azure is better than SQL Server running in any other VMs, right? Because it's Microsoft. You want to make sure that Microsoft software runs best. We also support non-Microsoft software, right? Obviously, Linux runs on VM. But especially if you're running Microsoft software, we have made optimizations to make sure that it runs best on Azure. Full VHD and application mobility. Again, if you look at other providers, you can do this. You cannot, take an on-prem VHD, move it to Azure, and move it back, right? Most providers don't allow that, right? Azure is the only provider that allows full application mobility. As long as it's SQL running in a VM, you should be able to convert. In fact, there is even a solution to be able to convert from VMDK if you're running VMware to Hyper-V, and it's a free solution that you can use, right? So that's something that I would say is a reason for you to think about. Hybrid, we talked about the scenarios. This is going to be very exciting in the next 6-12 months in terms of where the cloud providers would make investments. And from a Microsoft point of view and SQL Server point of view, you'll see a lot of capabilities coming down this way. And then what the gentleman asked, leverage the best of both worlds. Pick what is right for you, right? This idea of an open and a flexible data platform. If it's IaaS is right for you, go for it. If it's platform as a service, go for it. If you want to mix it, go for it, right? It's what works for your application as opposed to, doing one thing or the other. And I think that flexibility and choice, again, is I think, in my mind, is a compelling reason for you to try this out. And in summary, I would say, there is four things, right? SQL Server in a Windows Azure virtual machine, it's about reducing your total cost of ownership for existing apps. It's 100% SQL Server compatibility. If it runs in a VM, it should run in Azure. You got the control. You can essentially whatever you can do in the VM, you can even outside of SQL Server. And it's a managed infrastructure. There is a set of benefits that the platform is providing, right? So in terms of next steps, definitely go sign up for the preview. It's a free trial. You get 750 hours of compute. Go hydrate a SQL Server VM. Give us feedback. And there is a lot of interesting, step-by-step documentation that will take you. In fact, some of the demonstrations that we gave, we've actually documented that screenshot by screenshot. So I'll highly recommend you to take that. You can look at the pricing. After your free trial is over, you can take a look at it. Obviously, cost is a consideration for all the customers. You can make up your own decision. And give us feedback. There is an email address here. We are very anxious to get more feedback from you in terms of what works and what doesn't work. So that's all we got. Question? Yep. Okay, so the question is, the dashboard was showing a set of performance counters. Can we change that? Can a user change that? So the performance counters that you're showing on the dashboard are read-only. These are just graphic visualizations of the performance counter at the host level and the performance counter at the virtual machine level. Now, the existing tools that you have, like performance counters, you can still run them. You can still connect it from outside of the VM. The dashboard is just a coffee cup view. So, you get a snapshot. But the existing tools, you should be able to, read, write, whatever you want to do.
The dashboard does give you some flexibility about the amount of time that you track, whether it's like 1 hour or 7 days. But
yeah. And, we will have more visualization, in terms of, I don't want to see this particular counter. I suppose, looking forward, we'll customize some of that.
Yeah, you can switch them off now in the dashboard.
Second question, yeah. I see. So the question is, when you select a location, in some cases you don't want to know the location to make it confidential. That's a good question. I think at this point, if you looked at the experience that we have in the portal, it's more IT admin friendly in the sense that it gives you all that control, right? Now, if you have a scenario like what you said, where you don't want to show all that information, you may have to abstract it away. So all the controls you see in the portal are REST API based or PowerShell based. So there is nothing stopping any customer from building their own front end and exposing only the options you want to expose to your end customers. So you could do that. I would say, maybe this is a policy-driven thing, right? Like System Center has management capabilities to manage Azure VM, where there you could use certain templates to kind of say, I will only, allow my end customers to change these things. Other things, there will be a defaults, and there is an IT policy that will control. Yeah. Sounds good. Any other questions? Yes, go for it.
Regarding the licensing, are you going to support so you mentioned something else that the license for SQL Server like in the monthly basis?
Yes. Yeah, so great question. The question is, what about licensing for SQL Server in Azure VM? So there is basically two categories, and this is all. I'm talking about the general availability, because in preview all you got is the evaluation image, But in general availability, you will have two options. One, you already have license mobility with software assurance with Microsoft. In that case, you essentially got mobility rights. You have enterprise license, unlimited number of VMs on-prem. You should be able to just move your core licenses back and forth, right? Based on current licensing contracts. So that's one. That's the easy one, right? You got it figured out in on-premises. It just extends. The other case is where we will have a consumption-based model. So the experience would be something like what Amazon has today, right? You go to the Azure Gallery portal. There will be different versions of SQL Server, different images, and you can click on them, and it will say your monthly rate is this. It's actually an hourly rate, but it's a monthly contract. So that is likely what the experience would look like. And you can essentially stand up a VM, and you'll get charged for how much you use.
What does it mean how much you use per megabytes?
So there is a charge for compute, storage, and networking that Azure platform charges. The per hour is specifically for the SQL Server license.
What is the SQL Azure?
Sorry?
Is the SQL Azure, or are you talking about Azure, or are you talking about SQL in VM?
I am talking about SQL Server in VM.
There is another licensing option for the hosting company that can basically rent you SQL Server for €100.
Yes. So that's a great question. So the sub question is, what about hosters? So the hosters do have an option for volume licensing. It is called SPLA, Service Provider License Agreement. Yes, you could have that, right? And in fact, that's actually a good point. There is a third option if you are a hoster or a service provider where you can sign this volume licensing contract, and essentially you get a flat fee for volume licensing SQL Server. And I think that also has a period. I can't remember if it's monthly or bi-monthly. And once you get that, and if you are a hoster and you are providing that to your end customers, you get to charge however you get to charge. Essentially, your financial or licensing obligation with Microsoft is this volume licensing agreement, right? That's an example of that is what we do with, for example, our partners like Amazon, right? Amazon or Rackspace, anyone who runs SQL Server, essentially has a relationship with Microsoft as a licensing partner, and they get volume licensing rights, right?
I don't talk as a hoster, I talk as a client.
I see.
I'm wondering why Microsoft doesn't provide this.
I think there is a volume licensing. I'm not a licensing person, but I think there is a volume licensing option also for clients, especially big clients, and that becomes very close to enterprise software assurance. So this will fall into the first category that I talked about. It looks very similar. The enterprise license with volume license looks very similar to software assurance.
What I want is to go there and say, I want SQL Server license for a month, for 2 months.
Yeah.
That's not enough.
Not today. Obviously in preview we don't have that option, but in GA, that would be interesting feedback for us. Why don't I do something, and I'll get your contact, and then perhaps we can get more requirements on what you guys are looking into. All right. Any other questions? All right. Well, thanks, guys. Thank you. Thank you so much.